Hi Fleetsters, my name is Mark and this question comes to us from Omar V. Omar asks, how far away is 1 light year? Omar, that is a fantastic question. A light year is one of those weird scientific terms that means something a little bit different than you might think it would, because normally a year is a measure of time. Like a year has 365 days, for example. A light year, however, is a measure of distance, which is kind of weird. The way the scientists define it is as the distance that light would travel in a year. So in other words, if you were moving as fast as the speed of light, that is 186,000 miles per second, not per hour, per second, then how far would you go in 1 year? Well, the answer to that question is about 10 trillion kilometers or 6 trillion miles. That is a really, really long distance. Just to give you an idea of how big those numbers are, if we went back in time 1 billion seconds, we would be in the year 1987. However, if we went back in time 1 trillion seconds, we would be in the year 30,000 BC. That's just 1 trillion, and there are 6 trillion miles in 1 light year. So it's a really, really far distance. And the reason the scientists use light years is because theoretically, light is the fastest that anything can move that we know about. So now you know how far 1 light year is. Great question, and keep them coming.
So slime, it took the nation by storm, and now everybody wants to make it. We've been making it at the Fleet for a long time. What is this cross-linking glue polymer all about, though? What is the science behind slime? Well, everybody knows that the world is made out of atoms. You and I are made out of atoms, the air we breathe, the water we drink. This is one of the atoms. They're all very unique, have a certain number of protons and neutrons inside, and the electrons buzzing around them. We have taken atoms, though, and we combine them together to make molecules. So here is a picture of water. It's connecting 2 hydrogens with an oxygen atom, all right? And we have a simplified drawing of that. And here's another one that's even more simple. Now, if we take a molecule and we connect it to another molecule and another, we can make a polymer. The individual ones are called monomers, like the water molecule. And if we connect them in a long chain, it's called a polymer. There are many natural polymers. DNA is a famous one. You can see every dot of color on here is a different atom. It's quite a long polymer. But there are other ones like the hair on your head or the nails on your fingers or even that tortoise shell. The cellulose in the paper or in your trees is a polymer, a natural polymer, as well as in the starch that's in your potatoes and corn that you eat. Lots of natural polymers. We're going to look at this one. It was formed by Elmer, a farmer. He boiled down the carcasses of his farm animals, and they had nails and hair, and he found out by boiling it down, you got a sticky substance that can help hold things together called glue, okay? So this is a chemical drawing of what glue looks like. You can see that there's oxygen to hydrogens in it. And it actually, the way it forms molecule to molecule is kind of a zigzag form called a polyvinyl acetate. You can see that some people just draw the zigzag part just to simplify it even more. Now, if you take one polymer chain and you connect it with another polymer chain, now you're really doing something. You're cross-linking them, and you're going to have something even stronger and stretchier. So here it is in our glue. We can take and connect. There's detailed drawing at the bottom, but that simplified drawing shows that the zigzag shape is connected to another zigzag shape of a chain of polymer, okay? So we can do that with borax. Borax will actually cross-link our polymers, and we can come up with a great stretchy substance, but you can also do it with Tide detergent from your clothes. You can do it with baking soda. Lots of different recipes out there, so have fun making slime.